I'm going to share my screen. Screen 2. I hope you can see my screen. Yeah, okay. Yeah, so today we'll do something else. We'll start input output. Again, we will touch upon only what is needed. We will not get into details. And you've already been doing input output in some sense. But now we will get into extra details, which I will cover today, and it will generally give you an idea about. Generally, the purpose is to generally introduce file I/O and how to read types. I mean, like any type of file. Okay. So, for example, you've done some file I/O when you did pandas. You had a pandas had a built-in method in a CSV file. So it kind of abstracts a lot of things for you. So now we'll go and get into a little more details about how exactly it is done. And again, it is at an abstract level because the internal details are covered the operating system and the Python libraries. So we will not get into the libraries. Okay, we will only see what are the what functions the libraries give you and what is happening inside. Okay, a high level picture of what is happening inside. And of course, see, I like I said, now I've been using Unix. So all examples which I'm going to show you today is on Unix, okay, on Linux, or it'll work on Mac also. But on Windows, I am not sure because I don't have Windows with me and I don't know much about it. So you can try, you'll have to find out the equivalent ways of doing it in Windows. Okay. You can raise this question in the lab session if you want, or you can post it in the Slack channel. Maybe one of the TAs will reply to you. Okay. Anyway, Linux is a better operating system, so I urge all of you to switch. Anyway, let's go ahead. So this picture we saw earlier in one of the first lectures. So this was parts of the computer, and one thing which we said was everything happens in the main memory, right? So there is a CPU which processes stuff, and actual operations happen in the registers, but the main memory is used as a temporary storage where you keep things, fetch instructions and data from main memory. But the problem with main memory is that it's volatile. What do you mean by volatile? What is volatile?
Which cannot retain it.
Yeah, it needs power. Okay, it requires power, because if you don't have power, if you pull the plug, the contents of the main memory gets erased, because it is essentially it's a set of capacitors. I mean, like when you implement main memory, most of the time is done with capacitors, like my miniature capacitors which are there in the VLI, which it's basically a chip. Like the electronic circuit is fabricated on a chip, and it is essentially a series of capacitors. And when removed, the capacitors get discharged. So to retain stuff in memory, because without doing that, you'll need to keep your computer powered up all the time, which is practically impossible. So you need to store your data and programs into a memory which is not volatile. That is, even after the power is removed, it will still retain its contents. So that is usually done using non-volatile memory, and that is done usually, I mean, these are all hardware, okay, and so this is done either using a hard disk, using flash memory, and maybe optical disk, or even tape. Okay, so hard disk is probably the most common, but it is fast getting replaced by flash memory. And optical disks and tape are used for archival storage. Earlier, optical disks used to be common, but that is CD-ROMs and DVD-ROMs. But these days, even that is going out of fashion. Most computers these days don't have a CD-ROM drive or a DVD drive. Tape is like the magnetic tape, which is usually used for archiving large amounts of data. So tape is actually usually for most people who use desktop PCs, you will not be dealing with tape. So tapes may be kept in like some libraries or in big companies where they want to keep record, because tape gives you a lot of storage at very cheap cost. Okay. So this picture again we saw last time as well. So this is that CPU box in a typical desktop. So so the non-volatile memory is in this case it's a hard disk, and the hard disk is actually a physical disk which is in an enclosure, and it is usually kept somewhere here, and it is connected to the system by cables. Okay, so usually there are standard connectors for hard disks. For example, SATA is a commonly used connector to connect a hard disk to the motherboard, and the CPU and all the main memory and etc. are all mounted on the motherboard. So this is a hard drive, right? And even in laptops, there are hard disks. So this one is a hard disk here. I think this. I'm not sure what laptop this is. Maybe it's a Mac. I'm not sure. So there is a hard drive here. So this is pretty similar to what is an HP. Looks like the power supply is an HP. So this must be an HP. So the hard disk is again for the laptop. It is a little smaller. Again, it serves the same purpose. Okay, non-volatile memory. And this is how the hard disk looks inside. So if you open the enclosure, there is a metallic disk inside. That is why it's called a hard disk. It's a metal disk, aluminum, I think. It's a metal disk, and there are these arms, like these arms here, which are actually. So the hard disk, the surface of the hard disk is coated with magnetic material, and these booms here contain at the tip here it contains circuitry which is sensitive to the magnetic field, and then it will by changing the magnetic field or by changing the magnetic material on the surface of the hard disk, information is stored on the hard disk. Okay, just like if you're not sure if you're familiar with an audio cassette or audio tape used to be there 30 years back. So something like that. Fine. So there is usually a platter of disks, and there are multiple arms which move. And the thing is, there are concentric circles on the hard disk, which are usually called tracks. And in a track, there are multiple sectors. So there is one sector, just like how you see in a circle, right? So there's an arc, and there is a sector in a circle. Similar to that, the hard disk is divided into multiple sectors, and every sector and every track will have a particular address, and the operating system keeps track of what is stored where. Okay, so if you want to access something which is stored in this particular sector, the actuators will move here. The actuators will wait for the disk to for the disk to rotate and come under the head, and then only the contents are read. Okay, so the point of all what I'm trying to tell you here is that it is an electromechanical device. So actually there is physical movement, and things have to rotate, things have to move, things have to come under the head. Only then the material is read. Whatever data is there is read from the hard disk. Or if you want to write, also the same procedure is there. You need to write at a particular location. So you have to wait for the disk particular track and sector to come under the head, and then only writing happens. So it is electromechanical. Okay, so that means it is slow. It is not very fast. But of late, these kind of hard disks are getting replaced by solid state drives, or which are basically electronics, and it has no moving parts. It is completely flash memory, and so because of that, it is also able to retain power. No, just like your USB disk, the USB stick is a kind of flash memory. So it is just like a USB stick. It is there, except that it is mounted inside the PC, and it has got connectors to connect to the rest of the PC. So SSDs, so solid state drives, are fast becoming common. Okay, and they are much more reliable and much more fast because there is no electromechanical movement here. It's very fast. Of late, I mean, like for example, in many laptops, ultrabooks and things like that, there is no separate solid state disk. The solid state drive itself is soldered onto the motherboard. Okay, so by which you can achieve a very thin laptop. Like if you are looking at very thin laptops like MacBook Air or things like that, usually the solid state drive is soldered directly onto the motherboard so that this will save space. But of course, the downside, can you tell me what is the downside of this? Anybody who's using an ultrabook?
Repairability.
Not upgradable, sir.
Repairability.
Yeah, it's not upgradable. Like
We
for
cannot
example, many
replace it.
cases, correct. Like for example, in many cases, if you have a system like this, if you want to change the hard disk, suppose it's a solid state drive also, you can add additional solid state drives, or you can, if you want to change the drive and install a drive with higher capacity, that you can do. It can be done by the user. But in a case like this, when everything is soldered directly onto the motherboard, it is not possible for the users to upgrade. And if something happens to the motherboard, or if some of the flash memory gets damaged, then you have no other choice except to replace the whole motherboard. Okay, so but this is but these devices are quite reliable. So usually a lap may be having a life of 5 years. So this will usually last enough for 5 years. So those are some glimpses into some of the hardware of what we are doing. So we are talking about non-volatile storage, and all what we saw in the last few slides were examples of non-volatile storage. Okay, so that means the power is removed, the contents of whatever is there are retained. Okay, so but why now, as a programmer, why should input be challenging to you? Main problem is the speed difference. Okay, the main memory and the CPU are very fast, nanoseconds, microseconds to access. But all the other devices, especially the electromechanical devices like optical discs and hard disks, are much slow. Okay, I'm talking about access time. So here this table compares different types of media which are there here. It is a technique or the technology which is used. This is the description, and it will give you some comments about what is the, and this is the capacity. This column gives you the typical capacity, and this is the access time, typical access time. Okay, like DVDs, for example, are optical discs, electromechanical discs. It uses lasers to read the contents. It's not magnetic, but it uses lasers. But the thing is that it takes typically milliseconds to seconds to access. Similarly, for hard disks are also electromechanical, magnetic devices, and capacity could be quite big. 1 terabyte to even 10 terabytes are not uncommon. And typically, when a hard disk is spinning fast, it takes only microseconds. Okay, but so most programs rely on something known as locality. For example, that means the general idea is that if you're accessing some data element at some point of time, it is quite likely that within a short time of that time, you will be accessing it again. So because of that, generally hard disks, with this constraint in mind, hard disks are generally reasonably fast with order of milliseconds. But still, if you now suddenly access a file which you have never opened for a long time, typically take maybe even hundreds of seconds or even a couple of seconds to access that particular thing. Disk has to rotate and come under it, and it has to the head has to read. We talked about solid state drives, which are definitely faster, microseconds to milliseconds, and it is there is no mechanical movement there, and high capacities are also available, but probably not as much as hard disks. Okay, so there is a cost difference. So the faster and larger it is, the more expensive it is. So in terms of cost per byte, hard disk is cheaper than a solid state drive. For a terabyte disk, you might get for like 3,000 rupees, but a 1 terabyte solid state drive will easily cost you some 7,000 rupees. Tape, like I said, is used mostly for archiving, and it can store very large capacities, like petabytes of data. So, like if you want to, SBI, State Bank of India, must be doing the millions of transactions every day. So, if somebody wants to see some transaction which happened 10 years back, it cannot keep storing all these records in archive, right? If they want to know what are the previous ones, they have to archive it somewhere else. So that is not usually done on disks, that is done on tape. So tape means some operator has to physically unpack the tape, load it into a tape reader, then the tape reader has to start, it has to rotate. So it can take as much time, several hours to read. Okay, suppose and tape is serial access. So if something is there at the bottom, at the last of the tape, you have to go through all the previous records and then reach the last record. So it can even take hours to access a particular data. But of course, these days everything is on the cloud. Cloud also is some server somewhere in the network, and typically those servers will have a hard disk or a solid state disk. But the bottleneck here is the network. The network which you have might have network delay. You might have enough bandwidth. So if you must all be familiar with the buffering of YouTube videos, and that those delays are typically due to the delay of the network. Fine. So there is a big difference in the access time of all these devices, whereas the CPU and memory are very fast. So the programmer will have to worry about what kind of device it is. What kind of device is the person accessing? So to avoid such headaches, the operating system abstracts all this for you and provides you an access to what is known as a file. Like a file is a data structure or a structure which provides an abstraction for a physical device. Okay, so in Unix, everything is a file. Not sure about Windows, but in Unix, my hard disk is a file. My monitor is a file. My computer is a file. What is there in my home directory are also files. So Unix abstracts it very nicely. And input output is performed with streams. So stream is nothing but so you can think of it as like a river. Once you attach a stream to a particular file, then you can transfer data back and forth through that stream. Okay, it's a sequence of bytes. So let's see various types of files. So here I'm talking about non-device files. Device files are special files which refer to a particular device. Okay, but here I'm talking about files with respect to files which contain data. So, for example, binary file is a named sequence of bytes. There's a text file, or which is also known as an ASCII file. Each ASCII file is a code is a character from the ASCII code. Okay, and there is a different type of file known as a formatted file, which is a file which has a particular style. Let's see. Can you give me an example of a binary file which you use commonly? Somebody give me an example of a binary file.
Power on, power off.
I'm sorry, power on?
I mean, switching action, if it is saved as a file, then it is a binary action.
No. File here, I mean a data file, a file which contains some data. I don't know why you said power on off. No, go by binary. Binary here means the content of the file is binary. Any example of a binary file? Maybe first you should see what's an ASCII file. Okay, maybe I have a, okay, wait. Let me go to my demo. Okay, so here is my my terminal here. Let me just see my file. Okay, so this is a so in Unix, cat is a program which reads a text file or reads any kind of file and prints it to the screen. So I've done cat my file. So this is the contents of my file. Okay, and this I hope you can see it, right? Yeah. So this is so you can read what is written there. So this is an example of an ASCII file. ASCII means you can read it directly because the contents of it come from ASCII code. What is ASCII code? ASCII code is this. This is ASCII code. Okay, ASCII code is like a 7-bit code. We have not touched upon binary and hexadecimal. That maybe we'll have a look, but just remember, binary means the sequence of it has only 0 and 1, and ASCII is a 7-bit binary code. So every character is represented by 7 bits. A bit is either a 1 or a 0. So 7 bits represent every character, and these are the characters which it represents. Some of them are control characters. Okay, these are if you are connected to a network or if you are connected to a printer and all that. So these are characters which represent specific controls, but these are the print characters which are commonly used in ASCII files. So these are, so you can see that there are alphanumeric characters, there are numbers, there are punctuation marks, symbols, uppercase, lowercase characters. And every one of these characters has a unique code, and that code is made up of 7 bits. And here, for example, here in the bottom, you can see the hexadecimal code, which is basically a number to the base 16, 16 to the base 16. So, for example, capital A in ASCII has the hex code 0041. Fine. So there is a standard table called an ASCII table. ASCII is a very old standard, and ASCII, but it is still used. And this file basically is a ASCII file, and every character here has a corresponding code. Maybe you'll see that in a minute. Let me see what is next. Okay, let's come here. So there is now for example, in Unix there is a hex dump program. So basically what I've done is this my file, right? Whatever is this plain text file. So in Windows, plain text file is usually done with what used to be called Notepad. I'm not sure if it is still there now, but in Windows 95 or something, there used to be a program called Notepad. I think it must be there now, or there must be some other.
It is still there, sir. It is there, sir.
Notepad typically meant
It
for
is, sir.
yeah. So Notepad is typically meant for handling and reading and writing ASCII files. So these are the ASCII codes. So XDump program will read an ASCII file and it will print out the ASCII codes. So for example, this is the content, what we just saw, human readable form, and these are the ASCII characters which make up these files. For example, now if you see here, this is an example of an ASCII file, right? THIS is 4 characters. So if you see here, this is small case THIS. So what is the character for small t? Code for t is 74. H is 68. I is 69. S must be 73. Okay. So that is what is 74, 68, 69, 73. These are this represents small t, this represents small h, I, S. 20. Can you tell me what will be 20?
So space.
Yeah, 20 is space. 20 must be space somewhere here. It must be there. Yeah, space is 20, right? And so on. So every ASCII line, I mean every ASCII character will have a particular code. Fine. So this is the sequence number. So like that, you can interpret exactly what is there in an ASCII file. Now, a binary file is not an ASCII file. A binary file is a sequence of bits which is not corresponding to ASCII. Okay, for example, an image file, a PNG file. You cannot open a PNG file with Notepad. Why? Because Notepad is an ASCII reader. It is looking for ASCII, and so if you give it a PNG file, it will try the file and it will understand that it is not part of the ASCII code, and so it does not know what to do with it. Fine. Okay, this was the hex dump, which I showed you now. CSV, we'll come back to CSV in a minute. Now, for example, I've got also an image here. So if I do hex dump minus C, okay. Now the screenshot of that ASCII, you can see this is the screenshot which I just shared with you. Okay, this is a PNG file. This is a image file. So I've got a separate viewer of FEH is a built-in, is a viewer in Unix, which is used to view images. So now I said that, so if I do hex dump minus C ASCII.png, oh sorry, so what is happening? It is because hex dump is just reading out the hexadecimal characters, and it is, since it is not part of the ASCII, it is showing it like this. But I'll show you something in the beginning. So I can use, I'm just printing the first few characters, the first 10 lines. So here you can see that now what I've done is I have that PNG file. I have opened it using my hex dump viewer, and you can see that only in the beginning it makes sense, because usually all these binary files will have some sort of a header which will contain ASCII characters. So by looking at this header, your operating system will be able to make sense of what type of file it is. Okay, so here it basically says that it is a PNG file. So the operating system will assign particular viewers to open that file. Okay, so there is usually a header for all binary files. Usually there will be a header. If the file has to be opened by some application, the application has to know some details about the file, what encoding is used, what is the what size, what type of file is it, etc., etc. So those kind of details are put in the header. And so you can, in the beginning there are some ASCII characters which constitute the header, but after that none of it is ASCII, because it is not ASCII, it is image data. So the image is encoded in some particular way and it is written out into a file. Fine. So none of them are really ASCII characters. Some of the codes might match some ASCII character, but it does not make sense to you as a human. Okay, you need special viewers are required, like a JPEG viewer or a picture editor or something, to open such files. Fine. Another type of file which you saw earlier was also a CSV file. The CSV is a comma separated value, and a CSV file is also an ASCII file, because you are able to read it, because it is made up of ASCII characters. So for example, so this is an example of a CSV file. So usually in a CSV file, the first line is usually the column headings, and here there are some data here which I've written here. And here, in this sense, this is a comma separated value, so it is separated by commas, but you can have separated value, or you can have semicolon separated value based on whatever application you're using. CSV is more common, and all these files may be called CSV. Okay, but it basically means that the different data elements are separated by a specific delimiter character, which is also a part of ASCII. So fine. Is it clear what I said so far?
Yes,
Last slide where you were showing that .g file opening. So over there, when you change the small from capital C, how did it make so much difference in the command?
No, that is because that is probably some option in hexdump. So if I see the man page, minus C is 1 byte character display, whereas capital C is hex plus ASCII display. So that is because, I mean, that is, so most of these Unix commands have various options, and different options mean different things. Okay, so so minus C is giving you 1 byte character display. So that is why every character is represented as 1 byte, and so that is why all those things came. But again, that might have also come because here I've not done a head. No? So I'm using head here so that I can see if I remove the head also, then all the things will come. I mean, like the whole file gets parsed. But if I use head, head will print only the first few characters, first 10 lines basically. So
the head prints the
Unix
first
commands
5
come with
lines.
various options by which you can choose what you want. Sorry.
So head to starting की 5 लाइनें बताता है, ये 10 की बता रहा है.
5 lines in the sense? I didn't understand.
Like, so if you are using the head, so there are 10 lines now, 10 rows. Actually, it
Yeah,
should be 5 now.
Head gives us 10 rows. Head gives you the first 10 rows, first 10 lines.
Okay, so.
Why 5? Why do you say it is 5?
Yes, sir, it should be 5 because in pandas we have 5. So I just think
Pandas
that
is different. I'm
it will be
talking
the
here.
5
This is
rows.
all Unix. This head has nothing to do with the pandas
Okay.
head. This head is a built-in command in Unix, which shows that head of a file. Pandas have taken that idea from there. Now, if I give head of minus 20, I mean minus 3, for example, then it will give me 3 lines. So this head is a built-in Unix command. Okay. So
Okay,
head
sir.
output the
Okay,
first part of files. Okay. Yeah. So I'm just doing this because I'm more familiar with Unix. So in Windows, there must be something equivalent, although Windows is not a command line driven OS. It's meant to be a GUI driven OS. But this head here is a built-in Unix command to view ASCII files.
Okay, sir.
Okay. Any other questions? Yes.
Sir, so all the file information is contained in these 10 headlines, like file date
In
of
the?
creation and file size.
No, that depends on the
In these 10
file.
headlines.
That depends on the file. For example, like if you are writing your own type of binary file, you will define some head. And if you have to read that particular file, you have to write a reader which will look for this particular header. Since you are the author of it, you know how the header is supposed to be. And so you will write your code so that it is able to make sense of that header. But now if you give that file to somebody else, unless that person knows what kind of header is there, that person will not be able to write a program to access your data because it is a binary file and only you know what has been written in the what has been written. So either you use some standard because most files have some standard headers. For example, all JPEG files have one particular header. All MP3 files will have one particular header. So for like standard files, there are standard headers. So if you have to generate, suppose you're cutting some audio clip and you're writing it out as a MP3 file, then you will have to use a standard MP3 header. So the header can be the header depends on, I mean, like, so the header is usually some kind of standard header, unless it is something very proprietary. For example, Microsoft might create some headers or create some files which are only viewed by Microsoft products. So based on how proprietary you want your file to be, you will make your header also either you will follow some standard or you will follow some closed standard, which only you and your company will know. I'm not sure if I answered your question. Is that right?
Yes, sir.
So these are standard files, so that those will have standard headers. But if you are defining your own file, you can write any kind of header you want. And if you want other people to and read your file, then you should provide a description of what is there in the header so that some other programmer can read that and write the code which will read your header and read your file. And many files don't have headers. So it is up to the person who made the file to know how to read it. Anything else? Fine. So those were, I talked about CSV files. Now now since you mentioned about pandas, so don't get confused with whatever there in pandas with whatever there is here, because see, many times same thing can be done multiple ways. There are multiple tools to do the same thing. Okay, so now for example, I have, I think, a CSV file here. Okay, so this is the same CSV file which I showed you in the previous in the slide. Now Unix, because it is fine, because see, most things in Unix are driven by text files. Nothing is binary in Unix except the programs, for example. But most of the configuration files are text files, ASCII files. And Unix tools have been designed to work with ASCII files. Now, for example, in pandas, you must have seen, right, how to pick up a particular column and all that. So you can do the same thing with in Unix also. Now, for example, there is a powerful tool called awk in Unix, which allows you to access CSV files. I should, by default, it takes space. So I will say that it is, I am saying that the delimiter is comma, and now it will give me the second column. Okay, so these are tools which are built into Unix. These are built-in tools in Unix. And so Unix provides lots of facilities to go through text files, because Unix is primarily made up of text files. All the configuration files are text files. So awk, there are various tools to manipulate and work with text files, and awk is one of them. Okay, so this is similar functionality which you do in pandas. But pandas, you need Python, you need to load the module, you need a big operating system, you need so many things. But all those things can be done very simply with Unix, because Unix already has built-in support text files. So if you want to learn more about it, you should look up awk and sed. There are various editors. There are stream editors there to manipulate text files. So and awk and sed are really, really powerful. If you know how to program, I mean, it has its own language, programming language. Awk has its own language. Sed has its own language. I mean, if you want about them, you can really, there are a lot of material available online. Okay. So this was CSV files. These are, I told you about binary files. So like I said, some application, example, an image viewer or whatever type of file you're opening, that kind of viewer is needed to make sense of the contents, because they are not ASCII files. So they are not ASCII. The encoding used in such files are not ASCII. So Python supports both types of files. Python can, so I hope now you know what is the difference between a binary file and an ASCII file. ASCII file has got ASCII codes. ASCII codes means it is made up of only these characters. Okay, but binary files, for example, if you see a Microsoft Word document, for example, you save something as a doc or docx. So those are not ASCII, because you require some application, Microsoft Word or OpenOffice or something, to read them, and those characters are not these characters. You have special fonts, you have bolded text, you have highlighted text, there are various colors are there, so many things are there, right, in a Word document. So that is why those are not ASCII files, because those are essentially not made up of ASCII characters. They are made up of specific characters which require external applications to read them. Okay, so Python supports both types of files, and really I think we'll be mostly dealing with ASCII files because it is easy to see, but nothing prevents you from using Python to read and manipulate binary files. So standard streams. So Python provides 3 streams. There is a sys module. There is the first input stream is the stdin, and there is an output stream, std out, and std error is the third stream. So input stream is normally connected to the keyboard so that the program can take input from the keyboard. Output stream, that is std out, is typically connected to the display so that you can see the output. And there is an error stream, std error, which so in case there is some mistake or there is some exception, some program crashes or something, it will generate its output and show the output to the input stream. So by default, the output stream is the display. So if the program crashes, so when you have this, if you're accessing a NumPy array and it is your index 7, which is not there in that array, it shows an index error, right? So that is an error. That kind of errors will be shown to the std error. That will be to the std error stream. And since the standard error stream is your display, it is getting printed to the display. In many cases, for example, like suppose you are working with a super, you will not typically have direct access to the stdin and std out or std error display, because it runs in the cluster, it runs somewhere in the cluster, it has its own display, it has its own memory, and so as the user you will not be able to see it. So all the output, these three streams are typically generated as output files. So if you want to see if your cluster, high performance computing cluster, if you're running some program and if you want to see if the program is correct, you typically have to go through log files to see what is the output, whether your program is giving the correct output or whether it's crashed, because that makes the computer much more efficient, because it is meant typically for non-interactive kind of jobs. Okay, so when you manipulate or when you interact with the program using your keyboard or the display, then that means the program is a program which interacts with the user. Like your Microsoft Word, for example, is a program which has to interact with the user. The user has to provide input. The user has to see what is getting displayed. So those things are there in a that is meant to be programs which are directly manipulated by the user. But many other programs, for example, batch programs, you do not directly have user input. Fine, it is a non-interactive program. For example, the an abstraction is there shown here. So for example, the method in Python and print method in Python is connected to the keyboard and display. And so this is abstracted in the following manner. The operating system provides a buffer for both these, for this stream as well as from this stream. So for the standard out stream and for the standard input stream, the operating system will provide basically two buffers. Buffer is nothing but data structure. So you can think of it as like an array. Okay, so if whatever you want to display or whatever you want to read from the keyboard is populated into some kind of a array. And typically once in a while, the operating system reads what is there in the array and prints it to the output device, whatever prints it or passes it on to the output device. So so there are buffers. So you as a programmer, the Python libraries provide you these two methods, which abstracts all these details for you. You don't have to worry about whether how the file, how the stream is opened, whether who is taking care of making sure that whatever you print is coming out onto the display. All those things are handled by the operating system. Okay, this is when you have standard in and standard out. Now the moment you change the standard in and standard out, like for example, when you do file IO, which you'll see in a couple of minutes, then you have to make sure that you have to take care of these things. For example, if you print to output stream, there is no guarantee that it is going to get written to the stream. You have to explicitly do something to make sure that it actually gets flushed to the output. That will, as a programmer, it is your responsibility to make sure that it is done. Otherwise, your program may not work the way you expect. Now, let's, what time? 47. Let's take a very simple example. Take this Python code. Okay, what is it doing?
Giving us the output of Addition of two input numbers.
Adding of
two
addition
input
of two
numbers,
input.
right? Yeah, this is not really a good program, at least from a user point of view, because it is not prompting the user for anything. But for the purpose demo, I think this is fine. So let me see. I must have some code here. What is it called? Read AR demo. Okay. Yeah. Okay. So now if I'm going to run this program, okay. Okay, what is it doing? It's just waiting for something, because it is, if you remember the code, it was asking me for input and output. So let me give some input, 4 and 6, and I got my output. Fine. So I gave 4 and I gave 6. Is my screen visible properly to you?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. Yeah. So this program is giving me this output, correct? 4, 6, 10, because this is the code essentially. So now, what is the standard input, standard output here? So I told Python has 3 streams. Okay. So this program is not generating any errors. So let's forget the error stream for the time being. But now it has to. Currently, there is an input stream and there is an output stream. So which is the input stream here?
4 and 6.
4 and 6.
No, 4 and 6 are the inputs. 4 and 6 are the inputs which I gave now. But which is the stream which it is connected to? Stream means, so you think of a stream as, like I said, no, like a river. Where is the input? What feeds that river? What is feeding that river?
Keyboard.
It is my
X
keyboard.
and
Yes,
Y.
it is my keyboard. My keyboard is
Okay.
what is feeding the stream. The stdin stream is getting by the keyboard, and the std out stream is the standard output stream. So what is the output? The number 10 is getting printed onto the output. Okay.
Display.
Actually, the 4 and 6 also get printed, because whatever I type, I want to see. So the operating system takes care of that also. Input and output were from the
So you were
So,
inaudible for some 10 seconds.
okay.
could you please
Okay,
repeat?
can you hear me? Okay, can you hear me now?
Yes, sir.
Okay.
Yes, sir.
Okay. So it's already 9:50. Shall I stop? Shall we do this tomorrow?
Yes, sir.
Yeah, let's do this tomorrow.
Yes, sir.
Yeah, let's do this tomorrow.
Thank you, sir.
Okay.
Thank you, sir.
So
Thank
we
you, sir.
will continue tomorrow. Yeah, we'll stop here. I'm not uploading these slides today. I will finish tomorrow and then upload it tomorrow. Okay.
Sir, can you please take a different session for window users?
No, man, I don't have Windows with me. So you should figure out what to do with Windows. I mean, like, because I don't have it with me, and I don't want to sit and learn Windows now. So Windows, there must be something similar. There must be, Windows has some command line, CMD command line is there. You can, but there isn't, I'm not sure if there is a cat or a head command. Those kind of commands may not be there. So for Windows, you will have to do things on your own, because I don't have access to it.
Sir,
Okay, you can ask,
ये
you can
ले
raise
सकते हैं
some questions.
because
Hmm?
sir TA सेक्शन ले सकते हैं because उनके पास तो
T-
विंडो होगा I guess.
Is also, you can post something in the Slack forum and see. You can post it in the Slack forum and see, because I think most of them also use Unix. Most of them use Linux. The problem with you guys is that you are not here. That is the problem. So if you were here by now, you would have done all this on Unix, because in case you get stuck trying to install Linux, there are other people to help you. But now, since you are at home with limited net access, it is better you don't touch your PC now. If it is running fine with Windows, let it run with Windows. So I don't know what is the equivalent thing in, because at least as far as the programming part is concerned, it doesn't matter whether it is Windows or Linux. I just showed you some of these commands which are there in Unix because they are just to tell you that those things are there. Okay, but that has nothing to do with the exams which you are going to get or the kind of questions you'll get in the quiz. Those questions in the quiz, etc., will not be specific to Linux. So that's fine. It is mostly the programming aspect only, which does not depend on what operating system you're running. Fine. So don't
Sir,
worry
is there
about it.
some difference
with
between
respect to-
Linux and Unix?
Linux is a more general term. I mean, so you can say Linux is derived from Unix.
Okay.
Yeah. So Unix itself is like a big universe. There are multiple types of Unix. There are multiple variants of Unix. And so Unix was developed in the 1960s, and it is still a very powerful operating system. I mean, like, it's a beautifully designed system, and that is how an operating system should be. Whereas the purpose of Windows was different. The purpose of Windows was to have a personal experience, right? But Unix was designed for supercomputers. But Unix has adapted very well to personal computing also, because it provides the GUI, has all those things. So, but the foundational design of Unix is still solid. It is super secure. Whereas Windows, you will probably need to install so many antivirus and packages and all those things. You don't need all that in Unix because fundamental design itself is secure. Anyway, so let's stop now and